Hello, good afternoon, good morning, everybody. Welcome to our webinar. Today's session is the Machinations 101 session. Today, we're going to give you a solid understanding of all the building blocks of Machinations. We're going to talk you through and help you master the different run modes, get familiar with the chart and its usefulness, and hopefully learn some tips and tricks along the way of how to keep your diagrams nice and tidy. And as always, plenty of time to ask some Q&As. Before we get started, what would be great is down the bottom of your screen, you'll see a little chat icon. Hit that chat button. If you could change the option on here as default, it'll say to all panelists. Open that up and change that to all panelists and attendees. And then if you can, just drop into the chat where in the world you are and which studio you're dialing in from today. That would be great to know where you all are. My name's Matthew, I'm the evangelist for Machinations, and alongside me as always is Cesar, our diagram craftsman and our master Machinations user. At the end of today's session, we're going to have we're going to open up the floor and invite anybody that wants to come up and have a chat with us to come off mute and come and talk to us. We can talk about today's model or just game design in general. Plenty of time. Please do ask your questions as we go. This is probably the 7th or 8th time we've run this 101 session. It's a nice small session, so plenty of opportunity to ask your questions. And as always, we're going to be asking you for your input and testing your Machinations knowledge. And we're going to do that via polls. So here comes the very first poll. How complex are your Machinations so far? And I'm going to use this to seamlessly transition over to my window. Perfect. So if you've not used it yet, if you're just doing some doodles, some subsystems, some full meta, or everything in there, brilliant. I'm going to close the poll in a couple of seconds. Here are the results. Actually, you've got a lot of people doing subsystems. Fantastic. Hopefully we'll have something for all of you today. Right, first thing, here's our window. Going to do something slightly different today because I'm actually going to show you some brand new features that we've got inside Machinations that will be being put into production in the next few days. So this is slightly brave because I'm going to show you our staging environment. So there might be things that are slightly different from what you're used to. First up, everything's still the same. I can drag and drop objects onto the canvas. I can drag them on and create some labels. Here's the wow moment. Labels look very different now. They've got a slightly just been redesigned, and I'm going to talk about this in a little while. When I've got my connection arrows active, so I can click this once, and it's going to completely mess up and not work at all. But it's going to put another object up in that direction for me. If I double click another object, it's going to jump all over the place because I'm in staging and I'm not in production. But you get the idea. It's going to put another object in that direction for me.
You had the connection selected. That's why.
Oh, see, user error. Machinations is perfect. It's just user error. There we go. Good. So I can do this in different directions. If I select an object, hold the control button, double click a source, it's going to put it down. If I hold shift and control and double click it, it's going to put it to the left. From these connection arrows, I can drag something from here and create a resource connection from it as well. So lots of different ways of kind of really quickly being able to build up your models. But now let's actually talk through what all these objects are. So down the left-hand side here, I've got my 11 objects. We're going to move through these in order, and I'm going to show you what they all do. First up, let's talk about sources. So sources are how we introduce resources into our canvas. When I hit play, you'll notice that each of these sources are using a different activation state. That's controlled here through the properties panel on the right hand side. So I have passive, interactive, automatic, and on start. So my passive one is going to wait for something else to trigger it. You'll notice while the simulation's playing, these are going to get grayed out because there's nothing active in that little setup. Here's my interactive one. Interactive only operates when you're playing the simulation. When I click on that source, it's going to fire one resource over to the pool. Automatic, it's going to send resources each step. And on start, it's only going to carry out its action on the very first step of the simulation. So here when I hit play, you'll see it sends one resource across. Cesar, what are you going to use your sources for in your models?
Sources are able to generate unlimited resources. That is why they are very useful for actually milking them of resources, so to speak. If you need to get currency and you need an infinite amount of currency to get, you're going to use a source. If you need to give your player HP items that come from nowhere, do not transform from other items, they're going to come from a source. Materials, basically any sort of currency in a game is going to come from a source probably. So
perfect. Up next, we're going to talk about drains. Now that we've got some resources onto our canvas, how can we get rid of these? So just as we've seen before, and we're going to see this with all of our objects, we have those 4 different activation states. My passive ones are just going to sit there waiting. My interactive one means when I click on this, it's going to drain one of those resources from this pool into the drain, and then it's going to be destroyed. My automatic one's going to carry out its action every step. It's going to automatically trigger. And on start, it's just going to carry out its action on the very first step. Now with drains, as well as pull any, we also have a pull all function. What this is going to do, we'll watch this here on our interactive drain. It's going to only carry out its action when there's 5 resources available. So if I try and click this before then, it's not going to work. Now there's 5 there, it will work. Now there's not 5, you see it flashes orange, it tries to carry out its task, but it can't. And here on the automatic one, as soon as there's 5 resources in here, the drain's firing and draining down that number. It's important to note that if with a pull any, it's going to pull up to 5 resources. It's not going to it's still going to pull 1 across if there's 1 available. And obviously on start, important thing to note here is that because there weren't 5 resources in there the very first step of the simulation, it's not going to trigger once there are 5, it's just going to sit there passively waiting. So Cesar, what are you going to use your pools for? Your drains for?
Your drains. I'm going to use my drains whenever I want to remove resources from the execution. So, for instance, when the player spends coins on something, you can use a drain because you're not really transferring them to another place. It really depends on the game here, but when the player loses HP, for instance, you're going to use drains. Any type of loss of resources that does not get transformed into another resource that is just outright lost is going to be modeled with a drain.
Perfect. Up next, we're going to talk about pools. So pools, incredibly important once we've created resources, where we're going to keep them. Now, just as we've seen before, we have our passive, interactive, automatic, and on start characteristics. Here, when I fire this pool, it's pulling across 1 resource with its pull any action. You'll notice all of the sources here are passive, so they're just waiting for something else to trigger them. Our automatic pool here is pulling 1 resource across each step, and our on start behavior is pulling 1 resource across on the first step, and then it's waiting. Now, one of the things that I know caught me out a lot when I first started using Machinations is having an active automatic activation state on a source and an automatic activation state on a pool. When I hit play here, despite there only being 1 on this resource connection, it's pulling across 2 resources. That's because as well as the source automatically pushing 1, the pool is automatically pulling 1. Something certainly to look out for when you're building your models if you see too many resources flowing along your connections. Now, as well as pull any, we also have push any. But there's nowhere for these resources to go, so they can't be pushed out. That means that it's going to get grayed out, and it's going to come up with that error message, tell me what's going wrong there. So anytime you see, when you hit play, something gets grayed out, you can quickly see what's going wrong. Here we have some push any pools with somewhere to push their resources. Passive, it's just going to sit there and wait. Our interactive, when I click on this, it's going to push one resource. And here our automatic one is sending it across each step. And obviously on start, it's just waiting in a passive state once it's carried out its first action. Just as we saw with drains, we also have a pull all and a push all. So let's just look at pull all. So here it's going to wait until there's 5 resources available, just as we saw with the drain. Once there's 5 there, I can trigger that and it's going to pull them across. When there's not 5, no matter how many times I click it, it's not going to do anything. And exactly as we saw with the drains, if we use the pull any characteristic, it's going to pull up to 5 resources each time. Here's the example using push all. So here, exactly the same behavior, but this time, rather than waiting to pull them, it's pushing those resources into the next pool. So here's our interactive one. Click on this, it's not working. Once there's 5, it'll send them across. A couple of other things just to show you as we wrap up on pools. The first one is showing numbers rather than the resources. So on the left-hand side here, I can see the counters building up. Once this goes over 25, it's now going to start showing the number. On the right-hand side one here, I've configured this with a capacity display limit of -1. The reason I've set that at -1 is that 0 is higher than -1, therefore it'll show the 0 there while the pool's empty. If I wanted that to be empty, I could set that at 0, but once it starts receiving resources, it will show a number. So I'm going to leave that on -1 so I can see that it's empty before I start playing. We also have our capacity limit. So on the right-hand side here, I've set a capacity limit of 4 using the overflow characteristic of block. When I hit play, our resources are going to come over. Once it reaches 4, it's then going to stop any more resources trying to get into that pool. Whereas this bottom example here, I've got this configured to drain. So each step, once it gets past 4 in this pool, it's then going to pull those resources over, but they're going to be drained from our simulation, removed from our canvas, and deleted. Another important thing to look out for, just as we saw our double automatic state before, here we have a automatic pull any pool and an automatic push any pool. But that means that this pool is trying to pull resources in, and it's successfully doing that from the source. This pool is trying to push resources out. So it means there's nothing to move resources between these two pools. So always look out for your push-pull combinations and make sure you've got them configured the way you want them for your game mechanic. Now, Cesar, you've got a fiendish puzzle for us today. Do you want to talk us through what we've got here?
Absolutely diabolical puzzle. We have the 3 nodes that Matthew presented so far. You can see that all of them are automatic. And you can see that we have 2 connections from our pool to our drain, 2 separate connections connecting the same 2 nodes. The question here is, after 3 steps of execution, so Matthew is going to hit play after asking the question. After 3 steps of execution, how many resources will we have in our pool in the middle?
Perfect. And I'm going to get you to see if you can answer this question via polls. So here comes the poll. How many resources in this pool after 3 steps? Is it 3, 6, or 18? Do your maths on your fingers if you can. So we've got an automatic source, an automatic pull any pool, and an automatic pull any drain. We've got a 4 on this connection, we've got a 2 on this connection, and we've got a 1 on this connection. Let's see who can get this one right. I hope there's lots of you that can get it. I'm going to give you a couple more seconds to do that maths on your fingers. Then I'm going to close the poll in 3, 2, 1. Let's see how people are doing. So 18 is the top answer today. Good. one with 3 and a couple with 6. Let's see what happens when we go through our 3 steps. So the first step, I'm sure a couple of you have realized what's happened now. So we've got 8 resources in there because of that double automatic state. Next step, we lost 3, but we gained another 8. Next step, lost 3, but we gained another 8. Therefore, it's 18 was the correct answer. If you got that one right, pat yourself on the back. Cesar was trying to catch us out there. So Cesar, where are you using pools in your Machinations models?
So it's highly likely that any model you will ever do, pools are going to be the most present node, because pools are basically used to store any resource that you have, and you're going to use them as, I don't know, if you want to keep track of the player's currency, you're going to do it in a pool. Player HP, you're going to do it in a pool. Player inventory, player items, in a pool. Even things like stats for a player. So a player's strength, you're going to keep it in a pool. A player's agility, you're going to keep it in a pool. A car's, I don't know, horsepower is going to be in a pool. So anything you can think of that stores resources, you're going to use pools for them. So they're the most basic and useful node of Machinations.
Perfect. Thank you, Cesar. Up next, we're going to talk about gates, this beautiful diamond-shaped object. Just as we've seen before, we've got these 4 activation states. Here, I've got a source. When I trigger my gate, it's going to pull 1 resource through and fire it into this pool on the right-hand side. Our automatic one's going to do this each step. Where we see this used a lot is where you have multiple choices and we're creating different pathways for the resources. So here I have a deterministic gate. Gates can either be deterministic or random. Deterministic means it's going to exactly match the options coming out. So these 2 pools will fill up at exactly the same rate, and it's going to evenly distribute them between them. Here I have a randomized gate, which means because we're in a webinar, they're going to be perfectly balanced. But I can assure you there'll be some randomization in this, and they'll fill up at slightly different rates, just as they would in the real world. As well as being able to use whole numbers, we can also use percentages. So here, the same models. This one's deterministic with percentages. This one's deterministic, randomized with percentages. Really important that you can never mix whole numbers and percentages. So you'll notice when I hit play here, this is going to be grayed out. It's going to show me the error message of what's happening. When using percentages, they don't have to add up to 100%. So here I've got a total of less than 100%. This means that the remaining 50% will be drained from our simulation. If they're over 100%, Machinations platform will add up and apply these at those ratios. So although this is 200%, it's going to add these up to be 50% chance each. Just as we've seen with our drains and our pools, as well as pull all, we also have pull any. So here with pull all, you'll notice our deterministic gate is waiting till there's 5 resources and then firing them through. Really importantly on this is that the gate's going to remember how it distributed those resources between each step to make sure that these pools fill up at the same total rate. So you'll see they now both have 10. The next time it goes through, the top one's going to receive 3, the bottom one receive 2. Next step, the top one's going to receive 2, the bottom one's going to receive 3, keeping them balanced all the way. And our randomized example, you can see these are filling up at slightly different rates. The last thing that we can do with gates is actually use these to trigger other objects. So here I've got a deterministic gate triggering 2 sources to fill up some pools. Here it's deterministic, here it's randomized. So because we're in a webinar, it's perfectly balanced, but I can assure you if we run that for a long time, you'll see it could be slightly imbalanced. And luckily it's done that this time. Cesar, you've got a fiendish puzzle for us. Do you want to talk us through what we've got here?
Yes. We have our gate. For this model, we chose a deterministic gate because we want no randomness. We want the result to always be the same. You can see that the input is 5 and the outputs are 2 and 1, so it's not really matching the input. So with that in mind, how will the gate choose to distribute those resources deterministically? And the question is the same. After 3 steps of execution, how many resources will there be on the pool on the right?
Perfect. So start counting this on your fingers, see if you can work it out. I've launched that poll. Is it going to be 6, 10, or 30 resources in that right-hand pool? So we've got 5 resources coming in from our source into the deterministic gate with a 2 and a 1. How many are we going to see ending up in this pool? I'm going to give you a few more seconds. And then I'm going to end the poll in 3, 2, 1. Let's see. Oh, it looks like you're catching a lot of people out here, Cesar. So most people think it's going to be 6. We've got someone super smart that's guessed correctly at 10 and one at 30 who's super optimistic. Let's have a look. Let's see what happens when we hit play on here. So the first step are 5 resources come through. 3 went into the top, 1 went into the bottom. Oh, sorry, 2 went into the bottom. Next step, it's carried on that ratio. 1 more step, and we've ended up with 10 in the top pool. If you guessed 10 correctly there, give yourself a pat on the back. Cesar, talk us through how did somebody work out how many resources were going to go in the top there?
Yeah, so the approach for this wasn't to try and figure out what's going to happen during every step. That wasn't really necessary. I mean, it is an approach, but if I were to answer this step by step, I wouldn't know the result either. The easier approach is to look at the proportions of the outputs, which are 2 and 1. So the top one is always going to receive twice the amount of resources that the bottom one does. You count the amount of resources that are going to be transferred in those 3 steps. So you're going to have 5 times 3, 15 resources. And based on those proportions, top side is going to have 10 resources and bottom side is going to have 5 resources. So you don't have to count them for each individual step.
Fantastic. Thank you, Cesar. Before I keep on forgetting to show people this, important to note that gates all operate during the step. So we can even have multiple gates all being executed during each step of the simulation. So here's an example. I've got 4 gates. You'll notice the resources are filling up in these end pools at the same rate. And Cesar, what are you going to use your gates for in your models?
Yeah, gates are mainly, I mean, except for the trigger gates that Matthew showed you at the end, which are useful in their own ways, you're going to use gates most of the time to distribute resources in different directions. Any type of loot box that you'll have with random chances is going to use a random gate. Any type of random element, like the player choosing a path, for instance, or a drop being of a certain rarity, let's say, that's going to be randomized. Most of the time you will be using random gates because those are more give the execution more diversity, but deterministic gates are useful as well in certain cases. But any type of resource distribution that you have, they're going to pass through a gate.
Fantastic. Thank you, Cesar. Up next, we're going to talk about converters. So just as we've seen in all our objects so far, we've got these 4 different activation states. What a converter is going to do, it's going to take a number of resources on one side and output a different number of resources on the other side. So here, I click our interactive one, it's going to pull 5 resources in, and it's going to convert them into 15 on the other side. Our automatic one here, I've set up an example of pulling in 5, converting them into 1. So anytime you want to kind of change one number for something else or exchange it for something else, converters are the way to go. Just as we saw with gates, converters all operate during the same step. So even if you have a chain of converters, they're going to go all the way through. So it's one step from a source or a pool or a gate all the way through to another pool. Just as we've seen before, we also have pull any and pull all. So here with a pull all, you'll notice it waits until there's 5 resources available, pulls them through, and outputs 1 resource. Now, between these two, you'll notice the right-hand side pool is filling up at exactly the same rate. With a pull any configuration, it's still waiting for those 5 resources to be fed into it, but they're hiding inside the converter. They're not showing where they are. Whereas with pull all, they're left in the previous pool and then pulled through. With converters, it's really important to get that pull all or pull any configuration right, especially when we have multiple inputs. So here you'll notice these two configurations are the same, pull all and pull any. With our pull all, this bottom pool, which is filling up faster because it only requires 2 of this resource, it's showing those excess resources there. Whereas in this top model, those resources are being pulled into the converter and are hiding in there, and we can't see how many there are. So it's especially important if you've got one crafting mechanic, as an example, where you need 2 of a certain type of item to be able to craft something. You don't want all of those hiding away in our converter. Important to note, you can only have 1 output from a converter. So here where I've tried to set up 2 outputs, I hit play, it's going to get grayed out and it's not going to operate, and there's my error message to tell me why. If I wanted to have multiple outputs, say for example you had a mechanic where a player could take an item and break it apart into multiple components, what I could do is set up a deterministic gate so that the player broke apart that item and distributed it into multiple pools. Now, Cesar, let's see your super fiendish question for us on converters.
Yeah, so we have the previous nodes. We added a converter in here. It's set to pull all, and it's automatic, so it will attempt to perform its action each step. You can see that it has 2 inputs coming from the same pool. Since we have 2 pools in here, we're only interested in the one on the right. Question is the same. How many resources will the final pool have after 3 steps of execution?
Perfect. And I'm going to launch that poll. I've been sneaky here and helped you all out by removing one of the wrong answers. So give it a go and see if you can come up and work out what the answer is going to be. I'll give you a few more seconds to drop in your answers. I'm going to end the poll in 3, 2, 1. Let's have a look at the results. So it looks like we still managed to catch some people out. Someone thought it would be 0, but a couple of people think it will be 12, and some brilliant people that think it's going to be 2. Let's have a look and see what happens after 3 steps. First step, our first pool gets filled up. This is where it catches a lot of people out. Our next step, our converter triggers. We've got 1 in that right-hand pool. Next step, we have 2 in that pool. Pat yourself on the back if you got that one right. It's a super tricky one, but if you're new to Machinations.
I noticed you removed the answer 3, which was catching.
We keep on catching people out.
Yeah. That was the nasty one.
So I took that out as an option to see how people would get on. So Cesar, what are you going to use your converters for in your models?
As Matthew described earlier, crafting is a perfect example for using converters. Having multiple materials turned into an object, an item, or even disenchanting or destroying an item to turn it back into materials. It goes into the same category. There are other examples such as, I don't know, converting a score into stars or converting experience into levels. Basically, when you need an amount of resources to obtain something, you're going to put those resources through a converter, and the obtained resource will be that something that you need, be it a star, an item, a level, or whatever else.
Fantastic. Thank you, Cesar. Up next, we're going to talk about traders. So before we get into traders properly, I'm just going to show you one other option that we have with sources, which is the color of the resources. So as default, it's always going to be set to black, but we can select different colored resources that the source will generate. So when I hit play, we've got different colors all coming into this pool. Then on my resource connections, I'm using a filter and filtering them back into their individual colors. The reason this is important is traders work with colors. So here I've got let me show you on the interactive one. Again, we have all those different activation states. Once there's 5 blue resources available, I'm going to trigger this, and it's not going to work because it's broken in staging, or I'm doing something wrong. So we'll just watch the automatic one. So this automatic one, once there's 5 of those blue resources available, it's going to trade these, and it's going to take 5 blue resources away, and it's going to give 1 black resource back. So this is a really useful mechanism, Cesar. What do you typically use these for in your models?
Traders, as the name implies, are used for trading. Think of them as, let's say, you can use a converter to model a shop that has an infinite amount of currency. So let's say that's a shop with unlimited money, but in a shop like, let's say in Skyrim, where the gold is limited in the shop, you would probably want to use a trader because both the player and the shop have currency, and both the player and the shop have items. And you just swap those items and currency between the two entities. And for that, you need a trader. It's the best node for that type of mechanic.
Perfect. Thank you, Cesar. Up next, we're going to talk about our delay nodes. Again, we've got those 4 activation states. Let's just follow along, see what's happening here with our delay node. So it's automatic and it's using the delay action. So each step, a resource is coming in. Each resource is delayed by 3 steps, then it's output into the right-hand pool. So it's a great way if we want to represent some time or something going on. The other configuration that we have is our queue action. What this will do, it'll take all the resources in every step. So 1 resource is going into the queue node. And what's happening is it's waiting for every 3 steps to output a resource. So whereas this one's going to take us 13 steps to get those 10 steps through, the one on the right-hand side is going to take 30 steps to get all 10 resources through it. Now I'm going to jump onto our connections and show you some of the amazing stuff that we've been building. And I'm sure you've already noticed with our labels that we've got. So first up, we're going to talk through resource connections. Now, one of the first things you'll notice is we've got this new design that's going to be into production in a couple of days, I hope, once we finish with all the QA and testing on it. So this actually, down the right-hand side in the properties panel, you'll see that we now have label, we have formula, and we have interval, all split out into 3 new boxes. With the label, this is where we can give it a logical label. So here I've given it a flow rate and a formula of 1, which is going to be the number of resources moving along it. I think we're going to have a sweepstake for how many times I'm going to try and put the number into the label box rather than the formula box as I get used to the change. But all of you are lucky because you're going to be able to learn Machinations with this model going forward. Now, when I hit play, where I have a formula in this first connection of 1, sending 1 resource across each step. Here I have a label of formula of 5, therefore sending 5 resources across each step. And here I've randomly typed a new label in there, but if that was empty, it would then just send 1 resource across each step. So 1 equals 0 in the formula label. Now, as well as being able to put a number of resources, we can put something like just the word all in there in the formula. This will send all the resources, regardless of how many there are, across the connection. As well as using whole numbers, we can also use D followed by a number to represent a number, 5-sided dice in this example. That could be any size dice that you want it to be. We can multiply that. So here I've got 3 times D5. Important to note here, that's not 3 d5 dice that are being rolled. It's 1 d5 dice that's going to be multiplied by 3. If I wanted 3 separate d5 dice, I could do d5 plus d5 plus d5. Doesn't matter if the letter D is capital or lowercase. And down the bottom here, I've got a whole number plus d5. So that's going to return a number between 7 to 11 each step. Rather than having to put in that weird little vertical slice thing that we have in our production right now, we now have a separate box for our interval. So I can just drop into this field what interval I want the resources to come across in. Here with 2, it's going to send 1 resource across this connection every 2 steps. Here I've got 5 resources going across every 3 steps. We can even use that dice mechanic on our intervals. So we have got 5 resources going across every d5 steps, so somewhere between 1 to 5. We can also do percentages. So here I've got a 50% chance of a resource being sent across. Here I have a 2 times 25% chance. And here I'm combining all of these different mechanics into one cacophony of a formula and an interval as well. Up next, we're going to talk about state connections. State connections are incredibly versatile in a number of different ways that they can be implemented. When they're placed between 2 pools, here I'm using these as node modifiers. So simply with a formula of 1, it's going to add 1 resource into this right-hand pool for each resource that goes into this left-hand pool. I can multiply this. So here I'm placing 5 resources in this right-hand pool for every 1 resource placed in the left-hand pool. And here I'm actually subtracting. So for every resource that comes into the left-hand pool, I'm taking 1 away from the right-hand pool. We can chain these together to create different types of effects. And we can also, it's important to note that these node modifiers only go in one direction. So if we take resources away from this left-hand pool, it's also going to take them away from these right-hand pools at the end of those state connections. This is a particularly useful mechanic if you're building a kind of certain metric that you want to be able to keep track of. So say, for example, this was our coin purse for our game, and we wanted to see, well, how many coins did the player receive throughout their entire gameplay? We could use this and actually use their spending mechanics on this right-hand side pool. So we can actually use these resources and do other things with them if we need to. It's important to note, and just to be careful, that here you'll see, although we've got 1 resource coming in here, which means we have 5 coming in here, they're actually getting drained down at different rates. So it can start to get slightly messy. So you need to be careful with how you're building out your mechanics when you're using node modifiers. Node modifiers in that type of configuration only work on pools. So if I try to do that into sources, into gates or into converters, you'll notice they get grayed out and it's not going to work. The other thing we can do are label modifiers. So rather than pointing these at an object, I can simply grab these, point them at the resource connection, it'll snap to the number. I can move this beautiful new number up and down the connection so I can get it the way I want it to look. And in this configuration, for every 1 resource in here, it's going to add 1 to the flow rate between my source and my pool here. Just as we could with node modifiers, I can do +5. So for every resource that comes in here, it's going to add 5 into this one. I can even do -1 to reduce that flow rate as well. By using a +1i on our state connection, here it's going to add 1 interval step for every resource inside our pool. We can even do -1i, which is going to reduce the interval in that flow. We can even combine all of these. So here we have we're adding 1 to the flow rate, and we're going to +1 interval to this connection as well. We can also increase percentages. So with a +1%, I can increase the chances of a resource flowing through this gate. We can do +1, we can do +5, or any number, and really start to control these, even minus percentages as well. Up next, we're going to talk about conditions. So with conditions, we can say whether or not this connection is available. We can use conditions on both resource connections and on objects. So here you'll notice the same behavior between these two models. As soon as this pool is above 0, so once it's received one resource, this connection is available and this source is available. We can do that. I seem to have lost some here, but that's all right. Here we've got some where it's only equal to 2. So these flows are only available while this pool's at number 2, or greater and equal than 3, or even ranges. Important thing to note between the ranges, so that's represented by 3.5 in this case. That means that this resource is available while this pool is 3, 4, or 5, not just the number 4. It's important if you're using conditions on objects that they have the correct activation state. So here, despite the fact that this is now greater than 0, nothing's happening from my source because it's a passive source. And there's nothing to trigger resources to flow between on this connection. Here, if I start this again, this is passive. So once it goes over 5, it will then be available. Here, the source is pulling the resources across the connection. And these conditions can be used on any other objects. So here we're activating a source, we're activating a converter, and then we're going to activate a gate, all using that same type of mechanic with a state connection. Up next, we're going to talk about triggers. What triggers will do whenever their source object is triggered, so it's receiving a pull or it's able to fire its action, it's going to fire and make the passive object trigger its action. So here, whenever this pull receives a source, it's triggering this source, which is firing it down to this pull. We can do that regardless of what the flow rate is, or even if there are multiple connections coming out of that source, they would all be activated. Very important to note, just as we saw with our conditions, here I have an automatic source. Well, the fact it has a trigger coming into it, it means it's not going to have an impact because it's already automatically triggering. How are we doing for time? Oh, we're good on time, good. We can even use these triggers to trigger pulls. So here's an example where my pull is a passive pull with a push characteristic. It's being triggered by this state connection to push its resources into the next pull. And here's an example of triggers being used to activate sources, converters, and gates all at the same time. We can even start to combine this logic and have multiple state connections between objects. So here I've got one state connection for greater than 1 to activate this pull. Once it's activated, it's going to start receiving resources. The next one is going to trigger its action and fire them into the right-hand pool as it should. Last one to show you is reverse triggers. Reverse triggers are a fairly uncommon item, but they're a great way of tracking when something can't complete its action. So whenever this converter can't complete its action because it's waiting for 20 resources, it's going to fire and trigger this source. So what I've done here is in this configuration, I've got this set up to count how many steps the converter hasn't been able to fire. Very helpful, and I'm sure there's lots of examples that we could find to show how to use them. Cesar, you've got another fiendish puzzle for us. What have you got for us this time?
One second, because I saw a question in the chat. Can I disable an automatic node? Sure, with a condition. And I believe that when Matthew's going to explain registers, we can show that as well. I mean, it's as easy as disabling any other node. Now, about the question at hand, this is the most mathematically challenging question we have. We have a source, a converter, and a pool at the end, and you see state connections flying all over the place, modifying everything there is to modify in there. So the question is, how many resources will the pool have after 3 steps? So the question remains the same, but this time the challenge is a bit harder. So keep in mind, have a look at all the labels, consider how those connections will modify those labels, and what will the end result be. Excellent.
So we've got an on-start source, and we've got a trigger coming around here as well to keep it going. So I'm going to launch the poll, and let's see how you get on. Is the answer going to be 1, 13, or 79 resources in that right-hand pool after 3 steps? I'll give you a couple of seconds. Do that maths on your fingers if you have enough, and see how you get on. I'll give you a couple more seconds, and then we're going to finish the poll. 3, 2, 1, go. Let's see how people got on. Yes, we've got lots of winners. You think it's going to be 13. A couple of people think it's going to be 79. Let's see what happens when we hit play and go through our 3 steps. So the first step is just the 1 resource. Now there's 1 resource in there. We've got a +2 coming into here. We've got a +1 coming into here. Bit of a red herring, this one, because it's before the converter. Therefore, there's infinite resources available here. And you'll notice that this state connection with its trigger has gone blue to say it's going to keep firing the source. Next step, well, we had 2 come across here, but actually we then had 3 come across into our pool. So we now have a 4 here. So we now have 1 + 8 on this connection, 1 + 4 on here. Third step, and we have 13 resources in the right-hand side here. I think if we'd gone any further, we'd get into some big numbers. Well done to everyone that got that one right. That's super tricky. I'm really pleased you're loving the new pill labels, Mihai. Couple of other objects to quickly show you. Up next are end conditions. End conditions are really powerful if you're looking to run quick plays and you want to have a condition that's going to stop the simulation and restart it. So here I've got a state connection with greater than 0 going to my end condition. When I trigger my source, this is now over 0. You'll notice my steps have stopped, and this is flashing to say that end condition's been fulfilled. We can put any type of formula in here, so it can be greater than 0, equal to 2, greater or equal to 3, or even 0. Oh, that's an interesting one. What have we got in there? Nothing. So here, if we have equal or greater than 3, if I have 4 in there, it's going to fire that and end the simulation. Up next, we're going to talk about registers. So registers are an incredibly versatile and powerful object inside the Machinations world, and we can do all sorts of things with them. And these, with these state connections, we're applying a identifier for their source data. So here I've got the letter A. Here I'm using the word letter, and here I've got a label of or a, and then a formula of word. So we can use a letter or a word, super cheesy. And what this is going to do, it's going to add up using the formula inside our register of A plus letter plus word, and it's going to give me the answer and start counting those up for me. As well as being able to use these to receive data and execute formula, I can then use these in an interactive state. So here I've made it interactive. I'm using a +1 on our state connection into here, and I can use this and tick this up and down as we go to control this flow rate. It's really important. Now I've made that 100. When I reset my model, it's going to drop that back to its initial value of 20. It's not going to remember exactly how many, what I've changed that to during the simulation. It's not going to keep that information. Registers can contain all of the maths logic inside them. So here I've got this set up as a logical OR register. So I have two formulas. I have larger A than 2 plus larger B than 2. So what this means is either of these pools are higher than 2. Because I'm adding them together here, it's going to use this to trigger an automatic object. So if this automatic object, if this register is now larger than 0, it's going to send this from a source. Exactly the same configuration, but rather than plus, I'm using times. So now if both of these are over 2, it's going to produce the number 1. Anything multiplied by 0 is 0. Therefore, this is a great way of kind of building up type of game logic to say only when both of these conditions have been fulfilled will we allow something else to happen. For those of you that want to get more into registers, highly recommend our Machinations 102 session, where we spend all of the time just really talking about everything that you can do with registers. I've just dropped the link into the chat for our Machinations 102 session on YouTube, so you can go and see exactly what we can do with it. Up next, I'm going to quickly show you our different run modes. So down the bottom here, you've been seeing me press play and stop and step down the bottom here. I can control the number of steps that I have in the simulation. I can control the speed of the steps down the bottom here as well and start building up my data. This is a chart of Super Mario Brothers, and it's going to calculate the score. Rather than watching this beautiful simulation, I might just want the data. So I'm going to hit quick play, and I'm going to push through 5 simulations really quickly. I can vary this, and I can say how many quick plays I want to do so I can gather that data really quickly. You'll notice the use of an end condition here, where once they've got to the end, it's triggering that end condition and the simulation starting again. So really quickly, I've built up a whole bunch of data to show how different players have got through this game and what score they've achieved across each of their runs. And because of that Monte Carlo simulation, it's going to be a slightly different answer every time. Thank you all very much for kind of going through our Machinations 101 session. Love to ask if anybody has any questions about anything they've seen today. I'm really pleased that we've had the opportunity to show you our beautiful new labels and our pill design, which I think just makes everything so much clearer inside your model creations. What's going to happen next is when you leave today's webinar, it's going to take you directly to a survey where we'd love to get your feedback on today's content, and also let us know if you have any ideas for any future content that you'd like to see. Once you've completed that survey, it's going to take you directly to our Machinations 101 model so that you can go through and you can have a look at this yourself and see how all those different configurations that I've been through with you today. As well as doing that, I'm going to drop into our chat all of our amazing ways that you can communicate with us. So we have our Slack channel, we have our Discord channel. Come and hang out with us on Clubhouse. We're on Twitter, and be sure to subscribe to our YouTube channel to get all the latest updates and content that we have coming up for you.